So in the text notes, you would have read about the percentiles and quartiles, and here we're going to apply that in a little practical example. So this spreadsheet data set is a little bit complicated, so we're going to step through it bit by bit. So first of all, at number one there, you have the arrivals data. This is the data you're already familiar with. This is the number of people who arrived to a restaurant in a 15-minute interval. So you can see that one time a single person arrived, then another time, one other time, two people arrived, and then three people arrived twice. And the data is ordered from lowest number of arrivals to the highest. Now, we configured that data horizontally so it's on the number line, so we can see basically, you can see all the data set running there from 1, 2, 3 on the left to 10, 11, 11 on the right in row 2. And above it, you've got the position of each number in the line. So this data set is ordered from the lowest to highest. And we then can put the position of each number in the data set above it. So the first number, then there's the second number, then there's a third number, all the way up to the 21st number. And that's on row 1. So that position of the numbers is a way of looking at the positions of pieces of items in the data set. So using these, we can then calculate percentiles. So the first thing we want to calculate is the median. We've already mentioned this before. The median is the middle of the data set. So the middle item in the data set. And you can see here that the median is, we have 21 data items in order. So the middle item is item number 11 because it has 10 items below it which are lower than it and 10 items above it which are higher than it. So in this case, the middle item is set to number 7 in cell N2 in the spreadsheet, and it's the 11th item, the 11th position. So 11th out of 21 is going to be the middle item. So you can also see there on the labeled area 3 that the median is calculated there in Excel as 7.0. It doesn't tell you which cell it is, it just picks the number. Now there's one unusual thing. I use the median function in Excel, which is correct and give the right answer. But then after I had created that formula, I copied and pasted it. So that's median G2AA2. When you copy and paste, the references go awry. That's actually median brackets D2 to X2. So when you do median D2 to X2, you get the answer 7.0. So in all of those functions, the G2 to A2 is actually D2 to X2, the numbers in the number line. So the median is the middle of the data set, right? We can also talk about as the 50th percentile. The 50th percentile is the number where it is approximately 50% of the items are below it and 50% above it. And when you apply the percentile function in it, that'll be the same as the median. So that's the number 7, which is the 11th item. And when you apply the percentile calculation in Excel, the percentile function, you specify percentile brackets, the data range to be analyzed, comma, 0.5. So the percentile in the Excel function is written as a number between 0 and 1. So that 0.5, that will give you the 50th percentile, and that's always going to be the same as the median. Next thing we want to often look at is the 90th percentile, because quite often statistics we want to find something that's got 90% of the data below it or only 10% of the data above it. And the 90th percentile in this case is calculated using the percentile function with the brackets specifying the range to be processed and comma 0.9. So what item has 90% of the data below it, and that's the number 10. We'll see it here. There it is, cell V2, number 10, and it has only 10% of the data above it, the two numbers 11. So the other very important percentiles that are often calculated are the first and this third interquartile. So the median splits the data into two halves. The first interquartile then again splits the lower half into two halves. And that's also because the median is the 50th percentile, the first interquartile is the 25th percentile. So Excel doesn't have a interquartile calculation, so you use the percentile calculation, and you get percentile. What's the first quartile or the 25th percentile? It's the number 5, and that is I2. So it's this particular 5 here. You can see there's 3 of them together, But this item you see has 5 numbers below it to the bottom and 5 numbers above it to the median. So it's right in the middle of the lower half. And then we do the same for the third interquartile. The third interquartile is the split of the upper half. So from the yellow 7 up to 11, there must be a split somewhere in the middle of that. And the split is the number 8. And it's at S2. So you can see here, there's the number that splits it, because between that and the yellow number, there's 4. Between that and the top number, there's 4. So this is exactly in the middle of the top half. And of course, in Excel, the calculation is the 75th percentile, 75% below all the way to the bottom and 25% up to the top. And that gives us an 8 again. Now, from that first interquartile and third interquartile, we can now calculate a new measure, which is a measure of dispersion. So we will calculate measures of position, and we can also calculate a new measure of dispersion, how spread out the data is. It's called the interquartile range, or IQR. And the interquartile range is simply the distance between the first interquartile and the third interquartile. And you can see the difference is 8 minus 5 is 3. And this measure of dispersion can be used instead of or as well as standard deviation or the simple range. But the interquartile range has one advantage. It's quite easy to calculate, but its main advantage is it's quite robust. You can see that this data set isn't too spread out from 1 to 11, but quite often the number at the very far right, there'll be some tiny numbers at the very far right, huge numbers at the very far right, or there will be some very tiny numbers at the bottom left. And when the distribution contains these outliers, which are numbers which are very far out from the center, they tend to highly affect the range. They make the range not very useful. They also have some effect on standard deviation, but they have no effect on interquartile range. So interquartile range is a good measure when you've got very high or very low outliers. Same example and same data set calculation, but we're going to explain the difference from an SPSS calculation. So in SPSS, we use the analyze menu, the descriptive command, and then the frequency subcommand, which we used in a previous exercise. But in that exercise, we want the frequency tables, but this time we don't. So you switch off the frequency tables checkbox, and you do select the statistics button. And from the statistics command, you can choose a variety of statistics, and we want the quartiles and the median. So that gives us Q1, Q2, and Q3. And when we run that output, we get this. We get the median of 7 and percentiles, the 25th, 50th, and 75th percentile. That's Q1, Q2, and Q3. So Q2 or median is the same, but Q1 and Q3 are not. The reason for that is that, as we talked about earlier on in previous exercises, if you have an odd number of total data items in your data set and you split it, you can split it neatly. So in this case, the total data set is 21. So the median is the 11th item. So that means there's 10 items below it and 10 above it. But when you go to split the data set, the lower half into half again, and the upper half into half again, they only have 10. So they have an even number. So if you're strictly going to calculate your median with an even number, you have to take the difference between two numbers. So that's what's going on with SPSS. It's taking the middle number. So if we take a look at that, just take a look at one example here. If you look at the lower data set here, there's 1, 2, 3. Well, you can see the number, and there's 10 numbers in there. So that means the middle of that number. So in the Excel calculation, is counting the median as an 11th number, and then it was taking the 6th, which worked perfectly. 5 below, 5 above. That's an inclusive calculation. The exclusive calculation is to ignore the median and just look at these 10, and then the middle number is in here. And the same goes for the other median, the other core Q3 in the top half. So you can use an inclusive or exclusive calculation, you get slightly different quartiles. And that means also that your interquartile range is different, because the interquartile range calculated in SPSS is 8.5 minus 4.5, which is 4 instead of 3. And that brings us to the 5-number summary, which is a very common way of summarizing all the descriptive positions we have looked at so far. So simply enough, the 5-number summary is minimum, Q1, the median, which is Q2, Q3, and the max. So you get the lowest number, the 3 quartiles, and then the highest number. In Excel, that's easily done. We've already calculated the middle 3 numbers, and all we have to do is use the min function to calculate the lowest number, and the max function to calculate the highest number. In SPSS, we can do it again using that command that we just discussed in the previous slide. Go to the Analyze menu, Descriptives, pick Frequencies, and choose Statistics. And this time, instead of just the quartiles and the median, you also choose min and max, and you get the 5-number summary. And that 5-number summary is so popular, it has its own chart or a graphical representation, which is a box plot, or sometimes known as the box and whiskers plot. And it's a great way of showing how the data is dispersed, how concentrated, where the centers are and where the edges are. And you can see that in that box plot, you've got the median, the interquartile range, the maximum and the minimum being used. And it's graphically represented. Now that box plot is often associated with calculations of the normality of the data, so we will leave that till later in the course.